In this problem, we are looking at multiplying these two rational expressions. A rational expression is a fraction in which the numerator and or denominator contain polynomials. So in multiplying these two rational expressions, what we want to do first is what we always do when we multiply fractions. We want to try to cancel any common factors in the numerator with common factors in the denominator. Well, the only way that we can do that with these polynomials that are in the rational expressions is we'll have to factor those polynomials first. Then we will be able to identify common factors that we can cancel. When you are factoring, my suggestion would be to look for any binomials that you have in the rational expressions and see if you can factor those first. Oftentimes, binomials are easier to factor than trinomials. If I look at this binomial, x squared minus 2x, hopefully I immediately realize that those two terms share a common factor of x. When I factor out the x, I get the product x times the binomial x minus 2. Let's consider this binomial. Hopefully we recognize that as the difference of squares. That's x squared minus 2 squared. That difference of squares factors into x minus 2 times x plus 2. So immediately I see a common factor here and here that will cancel to 1. So those common factors cancel to 1, and I've already started the simplification process before I will multiply what's left. Well, now I need to advance to these trinomials. Now, looking at the factor of x plus 2 here, there might be the possibility that x plus 2 could be a factor of that trinomial. 2 times 5 would make the 10. So let's see if we can construct a binomial that if we multiply it times x plus 2, the product under FOIL would give us that trinomial. Well, if this is plus 2, it would need to be minus 5 to give me minus 10 under the L of FOIL, wouldn't it? And x would have to be multiplied times 2x to give me 2x squared under the F of FOIL. Now let's see if this arrangement will give me minus 1x under the O and the I. The O of FOIL, it would give me minus 5x. The I of FOIL would give me plus 4x, and those two combine to minus 1x. So there is the correct factorization of that trinomial. And now I see that I can cancel the x plus 2 factors. Now, what I'd really like is I'd like that binomial to be one of the factors of this trinomial. And it does have the possibility, because 5 times 3 would make 15. So minus 5 times plus 3 makes minus 15. 2x times x makes 2x squared. Now the question is, does this arrangement give me plus 1x under the O and the I of FOIL? Plus 6x minus 5x is plus 1x. And now I can cancel the common 2x minus 5 factors. They cancel to 1. I've done all the canceling possible. What's left? There are only factors of 1 left here times x, so that gives me x in the numerator of my product. And the only factor we have left here in the denominator is x plus 3. Now, you might be tempted to cancel those x's, but remember that's not possible because this x is tied up in addition. We can't cancel terms that are tied up in addition. We can only, or even terms that are tied up in subtraction. We can only cancel factors, which means there has to be multiplication going on. So don't get caught by that trap that looks so good to fall into. There's our finished product, x over x plus 3.